So today I want to talk to you about navigating scientific resources using wiki-based resources, specifically those that are online. So consider how many of you actually run a wiki. That's a question that I will have asked today at the ACS meeting. How many people in the room are actually running a wiki? They're fairly common now. Of course, the most famous of all the wikis is Wikipedia. It's really revolutionized the way that we exchange data online. It is the reference place. It is the encyclopedia. This generation, that's where they go. The question is, how many people have used Wikipedia in the past week? I reckon most people. Who's written an article on Wikipedia is probably a much, much smaller collection of people. Who's found an error? Some people would say that they have. Whether or not they validated that error or whether it differed with their opinion is a different question. And how many people have edited an article on Wikipedia? I've used Wikipedia this week. I've written an article on Wikipedia, a couple, more than a couple. I've found errors on Wikipedia and I've edited articles on Wikipedia for sure. Of course, wikis are not just about Wikipedia. There are many of them around. They're being used inside pharma companies now. For example, Pfizerpedia, which is collaborative authoring for drug discovery, editable and by everyone at the company. They're being used in numerous companies now. And in science, there are so many scientific wikis. There's the Open NMR Project NMR Wiki. I'm an NMR jock, so it's one place I do go. Rational Wiki, Proteopedia, all of these media wiki sites supporting different types of scientific information. And of course, even Jimmy Wales cares about science and media wikis. He was actually involved in this article called Calling on a Million Minds for Community Annotation in Wiki Proteins. So the technical definition of a wiki is quite simple. It's a website which allows users to add, modify, deleted content via a web browser, basically using a rich text editor. That's technical definition. But of course, it's way more than that. People are using it to connect and collaborate. People are meeting each other online in these environments. They're working together. They're editing articles. They might not even meet for a long time. They may never meet, but it is an awesome place to connect and collaborate. It's also a place for discussion and constructive conflict. I'll give some examples shortly about constructive conflict that results in very positive outcomes. It's a very easy path, really, to set up an environment for you to engage the community. You could set up your own wiki to discuss anything you wanted, different colored flowers if you wanted. And it's not all about MediaWiki, despite the fact that that is one of the most common platforms. People are using different types of platforms to build their wikis. So WikiGenes, for example, isn't using a standard MediaWiki. And as I was commenting, it's a collaborative environment for almost anything, really. So you got Star Trek Online Wiki and Lostpedia for the Lost TV program. Anyone found it? Wikipedia for Star Wars. There's just so many of them out there. And in the Wikibooks world, there's actually a Wikibook originating from the work of Gary Wiggins and extended since then. Chemical information sources. The link is right there. I recommend you check it out. There's so much good stuff there. So you could say that with the opinions I'm giving you that I'm a poster boy for Wikipedia. I like it, I work with it, I use it, I've edited on it, I contributed to it, and yeah, I would say I am. I love Wikipedia. I think it's an incredible contribution to society. For chemistry specifically, there are thousands and thousands of highly detailed chemical pages now online. This one's for Taxol, a very detailed article. Just want to point out there, though, that Monroe E. Wall, right here, when I captured this particular screenshot, was not listed as a scientist on Wikipedia. We'll come back to that later. They have very detailed chem boxes. So for this particular compound, we see the chemical structure. We see a three-dimensional form of that. We see the UPAC name. One assumes that that was generated systematically using software, probably, not necessarily, but probably. We've got links out here to various databases such as Chembl, our own ChemSpider.rsc, PubChem, images from JMOL, the SMILES, the INSHE, the molecular formula, etc., etc. So that's a typical chem box. This is a drug box for Xanax. You do a search on Xanax, you'll find alprazolam through the disambiguation, and we see lots of other links out. It's very detailed, the articles are really good. A few years ago, I decided to dedicate some time to checking out the chemistry. As we were building out ChemSpider, I wanted to check the chemistry on ChemSpider and validate it against Wikipedia, and started seeing some issues with quality on Wikipedia itself. My opinion was that some of the structures on Wikipedia were wrong, and I know that a dedicated team of chemists have been building it. So the question was, what's wrong, what's right? So I spent some time over the Christmas holidays in 2008 working on it, and found some pretty interesting results. A later project we did was to look at the top 200 drugs on Wikipedia and to see that the drug representations were correct for these drugs. These are the top 200 selling drugs ranked at sales in US in 2006, and going through the data we were finding some pretty interesting errors there. Types of errors we found were structure drawing errors, so the molecules as represented were simply wrong. Stereo centers were wrong. Side chains were shorter or longer than they should be. A lot of misassociation of names and structures. Some of the UPAC names were incorrect. Stereochemistry would be wrong, or the UPAC name itself would simply not be a good fit to the compound that was represented. Links out to the databases were out to the wrong structures. Property errors were incorrect or hadn't been validated. And CAS number validation, where were people finding their CAS numbers? Because CAS numbers are meant to be very precise descriptions of the compound as registered in the CAS database, SciFinder. So I took a call to action for people to help in validating the CAS numbers. I could definitely check the chemical structures and validate against various sources. I could check the names and structure relationships. UPAC names were fairly easy to deal with in many cases. The CAS numbers were the issue. I don't have access to SciFinder. I couldn't validate them. I didn't want to validate it against chemical catalogs. So the place to do that was CAS. I asked online on the Wikipedia whether somebody with access could do that particular task. By this point, a group of us were actually working together to curate through the chemicals. There were a few thousand. My recollection about 6,000-7,000 at that time. Unfortunately, my call to action and request for help didn't really get the right response from CAS. They discouraged using SciFinder. This is direct, lifted off of the Wikipedia discussion page. And my particular stance on this was, well, if we can't use CAS to validate CAS numbers, then what can we use? There's no way to validate. We shouldn't be using Aldrich catalogs, for example. We should be using CAS. That was greeted in a very interesting way by the community. We had some extended discourse, mostly led by Martin Walker from Potsdam University. Some interesting discussions. There were discussions online, some interesting challenges online. And it wasn't too long, actually, before we got a new announcement from CAS that CAS was going to work with the Wikipedia project, which was a wonderful outcome. We're really glad it happened. We're so happy to have got this as an outcome, and as a result, we've been able to work together. The beneficial outcome for the community was the Common Chemistry website, where CAS put almost 8,000 chemicals of widespread interest up with the CAS numbers. We could then validate against those CAS numbers, and that helped us a lot to move the project forward. So thank you very much to CAS. That was a great outcome. By the end of the holidays, what I thought might be a 2 or 3 evening project to go through a few thousand compounds, because I'd been curating a lot on ChemSpider, I was actually full up. This is not my Christmas pudding. That's just actually not me, thankfully. But yeah, definitely had enough of curating Wikipedia chemistry, because it's a very, very interesting loop. A lot of conversations, a lot of discussions between us to make sure that we're getting to the right place. Even some of the work I would do, I would then get challenged on appropriately. I would add, and it would just keep going. Some of these compounds were taking days to curate. Just going back to the drug boxes for a moment, if you see this green tick mark, It is actually indicative of something. You will find these now in many of the drug boxes and chemical boxes on Wikipedia, and it's because the project took on a much larger life. A larger group of people got involved, and it is an ongoing project to validate the chemical data. I will say I do not do anywhere near as much of this as I used to. Once in a while, I am curating data, but the reason being is that it's pretty hard to find the errors today. The chemical structures have cleaned up dramatically. There has been a lot of work by a lot of dedicated people to get that done properly. We use Wikipedia on ChemSpider. We're very grateful that it exists. So for those of you who use ChemSpider, here's an example of searching on Taxol. You can scroll down the page and you will find the Wikipedia article. Please note we do make sure that the license is clear. And down here, the license is here. You can read the full article at Wikipedia one click away. So we're not harvesting the articles directly onto our site. We're giving you the path out to Wikipedia, and you can also edit the article at Wikipedia. We presently have almost 7,900 chemicals on ChemSpider that are linked out to Wikipedia. The Wikipedia collection, I believe, is much larger today. It's probably 10 or 11,000 chemicals based on what I've heard. So we are missing some of those links. We need to get back in action about making sure that list is more complete. And I have some nice news about that later. ChemSpider itself has some limitations. For those of you who use it, you'll realize that we only handle compounds where there are defined INCHIs, International Chemical Identifiers. We don't really handle polymers well today, minerals, many other materials where they cannot be drawn as structural representations and INCHIs generated. And we really don't handle reactions. Wikipedia, on the flip side, is awesome. Right? Here's a list of Wikipedia polymers, and then there are many pages of polymers, different types of polymers, addition polymers, inorganic polymers. There's lots of information. The articles are rich. There's minerals. So this is just the first part of the Wikipedia minerals list, beginning with B. They're very, very rich pages. I wish we had this type of detail sitting on our site. There's also named reactions on Wikipedia. Again, going off to very detailed pages about who did the original work and what's the value of the reaction, how do you use it, etc., etc. So, and as you can see here, following 200 pages are in the category of named reactions. However, just to bring you up to date on what we're doing with ChemSpider, we are working on ChemSpider reactions, working on rolling out 500,000 reactions to the community shortly. This will integrate to our ChemSpider synthetic pages project. Catalyst and catalyzed reactions from one of our graphical user databases will be integrated, as will methods of organic synthesis. And we're working on the developing support for materials right now. So imagine a world without Wikipedia, because recently when the US Congress were working on legislation that could potentially damage the freedom of the internet, Wikipedia took the site down for 24 hours, blacked it out. And there was a lot of support for bring it back, a lot of support for let's not get this legislation in place and damage us. We don't want to do without Wikipedia, right? I don't think there's anyone in this room who would like to see it go. But Wikipedia is a place of open discussion, and while it has its issues, and this article will tell you, the article on Wikipedia about why Wikipedia is not so great. It's an incredible place to find that, and there are issues, but they're open to the discussion, and that's what makes it a unique environment. I have my own issues. I wrote a couple of articles on scientists that I greatly respect, that I know, that I've worked with, that I've published with, and one of them is Sean Eakins. You probably know him. He's giving a number of talks here. He's in the domain of cheminformatics, QSAR modeling, etc. And I wrote the article, and I was flagged as a major contributor to the article, appears to have a close connection with its subject. Well, I would hope that contributors of articles on Wikipedia do have a close connection with their subject. Of course, this is a person. We're not married or anything, we're just friends. So I published with him. I thought I would know enough to write about him. I also think he's notable. For those of you who care about the measures of success in our domain of impact factors, etc. So he has an H index of 50. 7,700 citations to his papers. I would say it's fairly notable, and notability is one of the criteria for how to get onto Wikipedia. So I kind of got a little upset and I challenged the status quo because I asked the very complex question, why are porn stars more notable? Because their notability criteria, that I will not explain in detail, um, have porn stars become notable and get their pages on Wikipedia quite easily relative to scientists. I also made a little cartoon just to kind of engage a little further. It went to the front newsletter for Wikipedia, the signpost, and I got challenged on it. I appreciate the challenges. I understand I was trying to cause disruption, mostly to get engagement. Um, but the outcome of it was, over a separate holiday now, the decision was made that we would build ScientistDB. So because there are so many notability criteria on Wikipedia, not every scientist can have their page on Wikipedia without some significant work. We created an environment using MediaWiki where scientists, any scientist, can create their page. We harvested the Wikipedia content of scientists and set up MediaWiki, and you can go to scientistdb.com today, any of you, and create your own page. This is Egon Willighagen's page. In this case, he's got his LinkedIn profile plugged in. He has control over it. It's his. Other people can come and edit, but it's his page to work on. And that won't be a conflict. There is no conflict of interest for you to work on your own page here. This is Colin Johnson, who's an intern right now working with us, RSC, on ChemSpider and some of the eScience projects. He's a student at Chapel Hill. He's created his own page. We've supported a number of plugins. So, for example, the Mendeley profile that updates with all the articles. And as I said, LinkedIn. We've even got a Twitter feed here. So we're plugging things into our MediaWiki instance that are very different than what Wikipedia would allow. In fact, at a Skolnick symposium a couple of years ago, I said Sandy Lawson probably deserves a Wikipedia page, but the page didn't exist. We have created the page on ScientistDB. About 4 of us worked together on this to get this up, and the question is now, can it migrate to Wikipedia? And if anyone in this room is willing to help me, then that would be great. In parallel, we realize that if you are the host of a database, a scientific database, and try and write that up on Wikipedia, you can be challenged on that too, because there may be conflicts of interest and it may be looked at as advertising. So we created scidbs.com. If you have a scientific database, a chemistry database, feel free to go write about it there. We did the same with SciMobile apps. So if you have a scientific app, for example, many things Alex Clark does for iPad, iPhone, etc., he had nowhere to put them. He certainly can't put them onto onto Wikipedia, but why not on our MediaWiki? Participation on Wikipedia and our wikis, interested parties contribute for different reasons. Marketing and self-promotion are really one of the reasons why people participate, and there are very few selfless participants. So, SciMobile apps, we had 8 contributors only in 7 months, 7 contributors in 6 months for SciDBs. But as soon as you give people a place to put up their databases themselves on a database, ScientistDB, we had 38 contributors in 6 weeks. These slides are old, by the way. We've also used MediaWiki as the basis of Learn Chemistry Wiki, which is an environment the RSC hosts for students from secondary school, last 2 years of secondary school to end of undergraduate, to use it as a resource for learning. We've integrated it to ChemSpider, we've created some games and quizzes around it, and it's an environment of participation, so any teachers, any students can participate. It's a very, very simple interface for entry. It is a MediaWiki site. Because ChemSpider contains too much information, you can see on the left benzoic acid, there's so much information under those info boxes. But students, last 2 years of secondary school to end of undergrad, don't need all this information. So we simplified it down to very simple substance pages. And this is what they look like. Some very basic properties. You can see the Wikipedia link again here. And you can add, you can contribute to this with names and references, etc. There are quizzes, so you can actually interactively answer these quizzes and it will rank you immediately. There are detailed quizzes here. You can see issues around drawing structures, Lewis structures, resonance forms, and they give you the answers on the fly. It looks like this, so you can get some tips. The majority of this was all headed up by Martin Walker, the gentleman from Wikipedia Chemistry that I mentioned, works at Potsdam University. He joined us on sabbatical for a year. We've also got the ability to learn spectroscopy using a wiki. These are interactive spectra. The data comes from ChemSpider, but we embedded structured spectral display widgets into Wikipedia environment. So MediaWiki became capable of handling spectroscopy. In this case, you have a spectrum and you can draw the structure to see whether or not you've got it right. It's given you the formula, you draw the structure. Details of lab experiments and wonderfully detailed procedures. We're very happy that we've been able to work with the Wikipedia and done a lot with MediaWiki. We want to give back to the community. We have been working very hard on this Wikipedia chemical collection. We want to donate that back to anybody who wants to be able to embed links from their structure set to Wikipedia by chemical. If you're interested in receiving that Wikipedia, essentially it's going to be an SDF file with the appropriate links. Please contact me directly. Our only request is, please acknowledge that you sourced the data from us. That would be great. We've worked pretty hard to get it, and we will continue to update it. Some acknowledgements. The Wikipedia chemistry team continues to do amazing work, especially Walkamer, which is Martin Walker, Fiskim62, Dirk Beetstra, Edgar 181, and many others. There are many that we've worked with and connected with. The RSCE science team, Eileen Day specifically was the technical lead on Learn Chemistry, and one of our team, Alexei Pshenishnov, integrated to Spectra School. Martin Walker, as I mentioned, Potsdam University guided the Learn Chemistry wiki development. Sean Akins helped a lot with the spec of where ScientistDB, SciMobile Apps, and SciDBs would go, and he's one of the co-editors with me. We encourage you really to contribute to those wikis. Those wikis don't grow without contribution, and we simply don't have enough time to source all of your mobile apps and all of your databases and add them for you. We just don't have time, but you're welcome to do it yourself. And Alex Clark, who has made a lot of contributions to SciMobile Apps. So we thank him for that. Hopefully this was instructional as to how wiki-based resources can be useful for navigating science. Yes, this was about chemistry primarily, but ScientistDB is open to any scientist. SciDBs is open to scientific databases, and we hope that you take value out of it.